Hello everyone, today we are going to start the calculus. Calculus has numerous applications in the field of science, in the field of engineering, in the field of economics and so on. So as usual, you can take out your notebook and pen and start making your notes. Wherever you require, you can pause the video and take down the notes. In between the video, you'll get few checkpoints. You can pause at those locations and you can solve those questions yourself for better understanding of the topic. The answers of all these questions can be verified at the end of this video. So let's begin. Here is the index of this lecture. First of all, we will be seeing the introduction. After that, we will see the application of the differential calculus as well as the integral calculus. Then we will be majorly reading the differentiation. Under the differentiation, first topic will be the average rate of change. Then we will go through the instantaneous rate of change. After that, we will be reading the few important formulas of the differentiation. Then we'll go through the double differentiation. After that, we'll go through the maxima and minima. And then we will solve few good questions. And at the end, you'll get the answers of all the checkpoints. So let's initiate. In the development of the calculus, many people have the remarkable contributions from India, mainly the Madhav and Bhaskaracharya, and from Europe and Germany, there is Isaac Barrow, Sir Isaac Newton, the Cauchy, the Leibniz, the Kepler. So there are numerous people who have contributed a lot. So let's go into the details of the calculus. The calculus has primarily two branches, namely the differential calculus and the integral calculus. The differential calculus deals with the rate of change, while as the integral calculus deals with the accumulation of some quantities. Let us see the applications of the differential calculus. It can be used to determine the slope of the curves. It can be used to determine the maxima or minima. The differential calculus can be used in physics for determining the velocity, for determining the acceleration, for determining the rate of the radioactive decay. In chemistry, the differential calculus is used in determining the rate of reaction. In biology, if we go through the population dynamics, then we use the reproduction rate, the death rate. All these are the applications of the differential calculus. It can be used for the optimization. By the word optimization, we mean, let's say some company wants to launch a new product. Then what should be the price of that product so the company gets the maximum profit? This problem can be solved using the differential calculus. Let's say there is a dam. From dam, you want to bring the water to a hydroelectric power plant. Now, using which route you should bring the water? Which route will be the most economical one? This is optimization problem and it can be solved using the differential calculus. Let's take another example. Suppose you want to build metro in a city. While building the metro, there are numerous factors involved. The price of the land, the labor cost, the material cost. You should choose which route for the maximum profit. This problem can be optimized using the differential calculus. Okay, suppose we have a reflecting surface here and here is a light source. From light source, the light will strike the reflecting surface and then the light will reach to point P. How many ways or how many paths are possible? The correct answer is infinite. Why? Light can hit the surface like this and then it can go to point P. Same light can hit the surface like this and then it can go to point P. The light can hit the surface like this and then it can go to point P. So in this way, you can think of infinite pathways possible. Now the question arises, light will choose which path? How you will solve it? In geometrical optics chapter, you will see this derivation by the name Fermat rule. This will be solved using the differentiation. Okay, I am taking another example. There is a person standing here on the road and here is a pool. Now Someone is drowning down in the pool. This girl is asking for help. This boy can reach to this girl in how many ways? There are numerous ways possible. The boy goes like this on the road and then swims in the pool and then reaches to save the girl. The boy runs along the road like this and then takes this path in the water. The boy directly jumps in the pool and tries to reach to the girl. Which is the best path? How you will solve this problem? We'll be doing it at the end of the video using the differentiation. I'll take another example. Suppose you have two positive numbers x and y and you sum them up. X plus y is giving you, let's say, 100. And then if I ask you what is the maximum value of xy, how you will obtain? That can also be solved using the differentiation. Another example, let's say I give you a fixed amount of the material and then I ask you to make a cylinder of the maximum possible volume. What will be the chosen radius or the height of that cylinder? This problem can be solved using the differentiation. So we have the numerous applications of the differentiation. We'll read them one by one in this video. Now we'll be seeing few applications of the integral calculus. The integral calculus can be used to obtain the area, is used to obtain the volume or the area bounded between the curves. Using the integral calculus in physics especially, we will be solving the location of the center of mass, we will be obtaining the moment of inertia. Using the integral calculus, we can find the distance traveled. How? Take an example. If a car is moving with constant speed, how you obtain the distance traveled? It's simple. Distance traveled will be equal to speed into time. Okay. Now suppose that car is changing its speed. Then how you will obtain the distance traveled? Now can you directly use the formula distance traveled is equal to speed into time? Since the speed is changing, you cannot directly use the formula. Now how you will simplify this? This can be simplified using the integral calculus. What you do? The given interval is being broken into very small time intervals. And in that small time interval, can you assume the speed of car to be constant? Let's say infinitely small time intervals we are taking. So in that small time interval, you can assume the speed of car to be constant. Then that constant speed into that time will give the distance traveled in that small time interval. And can you do for all such time intervals and then sum it up? You will get the distance traveled. So this application we will see in the later on lectures. Okay. You can note down all these applications and then we'll initiate the differentiation. Let's start the differentiation, the major topic of this lecture. What is the meaning of the word differentiation? In simplest possible terms, differentiation indicates the rate of change. You can note it down, it's pretty important. Differentiation means, speak up, rate of change. Okay, good. Change is everywhere around us. In our daily life, we see so many parameters changing. For example, the babies grow. Such as if you look at your childhood photograph and your present face, is there any change? Yes, you notice so many changes. The temperature in our surrounding, it changes with the time. Sometime it increases, sometime it decreases. The price of the petrol, sometime it increases, sometime it decreases, so it changes. Your position, is it constant or it is changeable? It changes with the time. Next example, the ECG of a person. You have seen the electrocardiogram of a person. It's constant or it's keep on changing. Till it's keep on changing, the person is alive. When it becomes constant, game over. Another example of the change, your number of friends. Are they constant or they keep on changing? With time, your number of friends keep on changing. Another example could be the speed of the internet. Is it constant or it fluctuates, it changes? The answer is it changes. Next example is from cricket. The number of runs scored in every over. Is it constant or it is changeable? You know it is changeable. The interest rate in the bank accounts, is it constant or changeable? That is also variable. So change is everywhere around us. Every field has its own rate of change and we know them by the different names, such as if we talk of the cricket, the rate of change of runs per over we call as run rate per over. The rate at which your money will grow in the bank, that you will call as the interest rate. The beats per minute of your heart you will call as BPM. So changes everywhere. Getting my point? In this lecture we will be studying the rate of changes only. Fine. In order to learn the differentiation in a better manner, first we should learn about the finite difference as well as the infinitely small difference. So let's start with the finite difference. The finite difference is indicated by the symbol delta del or this triangle. You can see it on the board. We have a table where the values of y2 and y1 are given. Suppose the first value we consider of y2 as 100 and the value of y1 is 50. How much is the difference y2 minus y1? The answer is 50. This y2 minus y1 is equal to 50 is a finite difference. Okay. Next example from the same table, y2 is again 100 but the y1 is, let's say this time 99. How much is the difference y2 minus y1? It's 1 and this 1 is also a finite difference. Next example, y2 is again 100 and y1 is 99.5. How much is y2 minus y1 now? It is 0.5. This 0.5 is also a finite difference. Getting it? Okay. Let's talk about the infinitely small difference. Suppose we have the value of y2 as 100 and the value of y1 is 99.9999. There are so many 9 after the decimal. Then how much is y2 minus y1? Speak up. It will be 0.00000 and then somewhere there will be a 1. Now this difference y2 minus y1 is a finite difference or very small difference? You know the answer. Now the difference y2 minus y1 is very small. This kind of difference is known as the infinitely small difference and it is indicated by the symbol d. So here y2 minus y1 we can write as dy. What is the meaning of the dy? Very small change in the values of y. Getting my point? Let's take practical example. Suppose you get some pocket money and every year your parents enhance your pocket money. So the difference in your pocket money year by year is finite or infinitely small? Post your answer in comment box. Let's take another example. Suppose someone is working in a company and the company gives the annual appraisal to that employee. So that annual appraisal will cause a finite difference or will cause the infinitely small difference in the monthly salary. Post your opinion. Or the other example, suppose the company wants to deduct the salary on the name of the COVID. Then the deduction will cause a finite difference in the monthly salary or infinitely small difference. Post your opinion in the comment box. I am taking another practical example. The price of petrol, it keeps on increasing day by day. So that increment is finite or infinitely small. Post your opinion again in the comment box. And sometimes the price of petrol decreases. You can see the newspaper here. So the decrement in the price of the petrol is finite or infinitely small? You can post your answer again in the comment box. The correct answers will get 1 liter of petrol. Okay, fine. The decrement in the price of petrol is actually infinitely small, while as the increment in the price of petrol is creating a finite difference. I hope you get my point. So let's march toward the differentiation. Now we'll be dealing with the average rate of change as well as the instantaneous rate of change. Why we require two different rates? Let's understand it through an example. If we talk of the cricket, the run accumulated per over, you go through the average rate of change or you go through the instantaneous rate of change? Think about it and post your answer in comment box. Runs accumulated per over, you go through the average rate of change. On an average, these many runs are being scored per over. In few overs, you might score higher than that average. In few overs, you might score lower than that average. Getting it? The meaning of RPO, run rate per over. Okay, where you need the instantaneous rate of change. Suppose a car is colliding with a bridge. For damage happening to the car, which speed will be responsible? The instantaneous speed of the car or the average speed of the car? Think about it. The damage happening to the car is dependent on its instantaneous speed, not on the average one. Getting my point? So we are going to read the average rate of change first and then we will read the instantaneous rate of change. In order to understand the average rate of change, we are making here a curve. Let's say this is x-axis, here is the origin, and this is y-axis. And the equation of the curve is given as y is equal to fx. Okay. This is, let's say, x. Here the coordinate is x plus del x. What is del x? Can you speak up? Del x is the finite change in the values of x. Clear? Corresponding to x, here the value on the y-axis is fx, and corresponding to x plus del x, the value on the y-axis is fx plus del x. Okay. Our target is to obtain the average rate of change between these 2 points. Here is first point and here is the second point. To obtain the average rate of change, I am making a straight line here which is cutting these 2 points, and this straight line is known as secant. If someone asks us what is the definition of secant, then we should reply a straight line which cuts the given curve at 2 points. Okay. The average rate of change is basically equal to tan theta for this triangle. This is angle theta, this is del y, and this is del x. Average rate of change is equal to tan theta, and tan theta in this triangle will be del y by del x. Del y means what? Finite change in the values of y. So finite change in the values of y is equal to f x plus del x minus fx. And what is del x? Finite change in the values of x. Clear? And this is basically equal to the slope. We have already read it in the video of the coordinate geometry. Using the tan theta, we can find the slope of a straight line. And this straight line here is named as a secant. So we can write that average rate of change is basically equal to the slope of secant. Done? Let's take a practical example. Suppose I give you two lines. This is x-axis, this is y-axis, this is line number 1, this is line number 2. Which line has more average rate of change? It can be decided using the slope. The slope of line 2 is greater as compared to the slope of line 1. It means the average rate of change for line 2 is greater than the average rate of change for line 1. Getting my point? Let's take another example. Suppose someone asks you how much is the average velocity. I hope you might remember that formula. The average velocity is given as displacement divided by the time taken, and the displacement here we indicate as del s and time taken we indicate as del t. Okay. You can note it down up to here, and then we'll take the instantaneous rate of change. In order to understand the instantaneous rate of change, imagine this thing, these two black points we are bringing closer and closer, as close as possible. Then these two black points will coincide. In that case, the secant will get converted to the tangent, and slope of that tangent will give us the instantaneous rate of change. Okay, I'm making up the new graphs. So there will be a single point here only, because these two black points, they came as much close as possible, they coincided, and then here will be a tangent, and the instantaneous rate of change will be actually equal to the slope of tangent. Okay, the slope of tangent can be again given equal to tan theta, or we will write the same thing as limit delta x tending to 0 del y by del x. What is the meaning of limit delta x tending to 0? I am explaining this. In the previous graph, if you remember, here we had the x, here we had the x plus del x, and this distance was del x. Here we had the 2 points. If delta x is tending to 0, these 2 points will coincide. Do you agree? If these 2 points will coincide, then this secant will become the tangent. Getting my point? And this in turn in physics is written as dy by dx. What is dy here? Dy indicates infinitely small change in the values of y, and dx indicates infinitely small change in the values of x. Okay, let's take an example. Suppose someone asks you, how much is the instantaneous velocity? Instantaneous velocity will be d by dt of s or ds by dt. Clear? You can note down these things, then we'll go further. Now let's talk about the different notations used in the differentiation. In the beginning of this video, we had the talk that various people have contributed for the calculus, so they have used their own different symbols. First of all, we'll talk about the Leibniz. Leibniz used the symbol as dy by dx. The same notation can be pronounced as d by dx of y. It indicates what? The rate of change of y with respect to x. Suppose I write it as dz by dt. What you will pronounce? Write in the comment box. Correct. The rate of change of z with respect to time t. Okay. Suppose I write dA by dB. How you will pronounce it? Speak up or write in the comment box. dA by dB. The rate of change of A with respect to B. Okay, fine. Next is the notation used by the Newton. Newton used the notation as y dot or dy by dt. This y dot indicates the rate of change of y with respect to time. Next is the Lagrange's notation. Suppose you have a function f and you want to differentiate it, then the notation of that differentiated function will be given as f dash or f prime. For example, suppose we have y and we want to differentiate the y, then what is the symbol for that? Y dash or y prime. Okay. Suppose we want to differentiate the x, then the symbol will be x dash or x prime. One more important thing you should keep in the mind, that this d by dx or d by dy or d by dt, they all are mathematical operators. They just indicate the rate of change. You have already read many mathematical operators such as plus, minus, multiplication, division. Now you are going to read a new mathematical operator, rate of change. which could be indicated by d by dx, d by dy, d by dz, d by dt, anything. Okay, fine. You can note it down up to here and then we'll go further. Let's take a few examples in order to understand the average rate of change as well as the instantaneous rate of change. Question number 1. Suppose fx is equal to x cube. Find the average rate of change as well as the instantaneous rate of change. I am starting the solution. First part, you remember formula for average rate of change? Speak up. Del y by del x equal to f x plus del x minus fx by del x. I hope you remember the formula. So I am just going to put up the values in the formula. Wherever we have the x, we will be submitting there x plus del x. So the final value here will become x plus del x whole cube minus fx. Fx is given as x cube divided by del x. Can we simplify this thing? Yes. This is a plus b whole cube. How you open it up? A cube plus b cube plus 3ab. So 3x del x, a plus b, x plus del x, and minus x cube was already there. This all divided by del x. X cube and x cube getting cancelled out. This del x and this del x whole cube. So you are left with del x whole square plus 3x. This del x and this del x is getting cancelled out. X plus del x. Done. Now we are obtaining the instantaneous rate of change. Limit del x tending to 0 delta y by delta x. Del x is tending to 0 means del x is very small quantity, is almost approaching to 0. If del x is very small quantity, then its whole square will be how much? Negligible. So you can neglect this quantity. Okay. This del x is also approaching to 0. So what will be the final remaining answer? Speak up. 3x square. So if someone asks you how much is the instantaneous rate of change of this function, then your answer should be 3x square. If someone asks you how much is the average rate of change of this function x cube, then your answer should be this data. Okay. Might be you will feel few things typical at this point of time. With practice, the things will become further simple. You can pause the video here. You can give it a try yourself. Then I'll be taking up next question. Here is the next question. We have a function sin x and we need to obtain the average rate of change as well as the instantaneous rate of change. You can pause the video here and you can give it a try yourself. The steps are similar to what we have done in the question number 1. I am solving it here. First of all, let's say we want to obtain the average rate of change. In order to obtain the average rate of change, do you remember the formula? Del y by del x was equal to f x plus del x minus fx divided by del x. So putting up the values, sine, at the place of x you will be putting x plus del x everywhere. So this will become x plus del x minus fx is sin x divided by del x. Okay. Now you can open it up using the formula of sin a plus b. Do you remember how much is sin a plus b? Sin a plus b is equal to sin a cos b plus cos a sin b. We have opened up this bracket, that minus sin x is lying at its own place divided by del x. The next part was asking us the instantaneous rate of change. Do you remember the formula for instantaneous rate of change? For instantaneous rate of change, you write dy by dx is limit delta x tending to 0 del y by del x. So we have the delta x tending to 0 for this entire expression. So now pay attention as we are going to obtain the dy by dx. Sin x, as usual, you will be putting it here. Cos del x, the del x is tending to 0, so here will be 1. Instead of cos del x, I am writing here 1. Now here is cos x and sin del x. For del x tending to 0 means del x is very small, and for very small values sin theta was equal to theta, so here will be only del x remaining. Fine. And then there is minus sin x, putting that minus sin x here, this all divided by del x. See one good thing, this sin x and that sin x is getting cancelled out. Now this del x and this del x will also get cancelled out, so your dy by dx will be only cos x. This is the instantaneous rate of change, and this is the average rate of change. I hope you get this. It's a nice question. Later on we will learn this directly as a formula. If someone asks you what is the instantaneous rate of change of the sine function, you will report the answer as the cos function. Okay, note it down. Here is the next question. A square is expanding and we need to find the average rate of change of area as well as instantaneous rate of change of area with respect to the change in the side length. Question is pretty simple. It's similar to the previous calculation. You can pause here and you can give it a try. I'll be solving it on the board. So first of all, we'll obtain the average rate of change. The average rate of change will be indicated by del A divided by del L, rate of change of area with respect to the change in the side length. Now the area of the square is a function of length, and that function is given as L square because the original side of the square was L. Okay, let us simplify it further. It will be written as f L plus del L minus fl divided by del L. We know how to simplify this. In the given function, at the place of L, you have to submit L plus del L. So it will become L plus del L whole square minus fl is already available as L square divided by del L. This square can be solved using the formula a plus b whole square. So let us write it L square plus del L whole square plus 2L del L minus L square divided by del L. Here the L square and L square is getting cancelled out. Now simplifying it further, this del L and this del L whole square. So data remaining here will be del L plus 2L because this del L and this del L got cancelled out and this del L and this whole square got cancelled out. This is the average rate of change. Suppose we wish to obtain the instantaneous rate of change. The instantaneous rate of change is given as limit del L tending to 0 del A divided by del L. I hope you remember the formula. Okay. Now, if you look at this formula, in the del A by del L, you have to take the del L tending to 0. So in the del A by del L, if we consider the del L tending to 0, then what will be the remaining answer? 2L. Clear? So it's a pretty simple question. If someone asks you what is the average rate of change of area, this should be the answer. If someone asks you what is the instantaneous rate of change of area, this must be your answer. Okay, note it down. Now we are starting the important rules of the differentiation. Here is the rule number 1. The differentiation of any constant quantity is always 0. You can learn it logically also. What was the meaning of differentiation? Differentiation means rate of change, and if some quantity is already constant, what will be its rate of change? 0. For example, right now you are sitting in some room. What is the rate of change of volume of that particular room? 0. The volume of the room is constant, so the rate of change of volume is 0. Take another example. D by dt of number of eyes on your face. Number of eyes on your face, they are constant. Understanding that? So the rate of change of the number of eyes with respect to time should be 0. They are neither increasing nor decreasing, so there is no change. So the rate of change comes out to be 0. Another example. I ask you, what is d by dx of half? Half is a constant quantity, it will not change, so its rate of change will be again 0. What is d by dt of root 2? That will also be 0. Root 2 is also a constant. Okay. D by dy of sine 30 degree. That will also be 0, because sine 30 degree is again half, and the rate of change of half is 0. Half is a constant. Next example. D by d theta of sine square theta plus cos square theta. Speak up, what should be the answer? Sine square theta plus cos square theta is equal to 1, and 1 is a constant, and differentiation of any constant is always 0. Clear? Putting up the next example. D by dx bracket sec x plus tan x, another bracket sec x minus tan x. What should be the answer? Pause the video and post your answer in comment box. Correct. This answer will come out to be 0. This is actually an identity. Secant square x minus tan square x, which is equal to 1, and differentiation of 1 will again become 0. So you note down this rule. It's pretty important. Differentiation of any constant quantity is always 0. Now let's take up the rule number 2. Rule number 2 is known as the power rule. Suppose someone asks us how much is d by dx of x to power n. Then its answer will be n x to power n minus 1. Here n is a real number. Okay. I am taking few examples. If I ask you how much is d by dx of x cube, do you remember the answer? It was our question number 1 few minutes ago. Correct. Its answer was 3x square. Actually, you can obtain that answer using this rule. Check it. X to power n means x to power 3. 3 is a real number. Then answer should be n. N is equal to 3. Then x to power 3 minus 1, which is equal to 3x square. It means whatever questions we have done earlier, they all can be done using the rules of the differentiation. It will make your calculations quick. Taking few more examples. Suppose if I ask you d by dx of x square, then what should be your answer? Post your answer in comment box. Answer should be 2x to power 2 minus 1, which is equal to 2x. Few student might do a mistake here. Pay attention. This is actually wrong. You should not be doing this mistake. D by dx of x square. Those people who are having their 100% brain working, they will think that this square and this x will get cancelled out. This d and this d will get cancelled out, and the answer will be x. Do not do that. It's completely wrong. Okay, it's unethical. It's illegal. If there is a physics police and they see such kind of things, they'll put you behind the bars. Don't ever do that. D by dx of x to power 1, you can simply write as only d by dx of x. Then your answer will be what? Pay attention here. It will be 1 x to power 1 minus 1. 1 minus 1 will become 0. It means 1 x to power 0. How much is x to power 0? X to power 0 is always equal to 1. So this answer is finally 1. Okay. Now few people might get that x and x getting cancelled out, d and d getting cancelled out. Don't ever do that. Okay. This thing is also wrong. You should never be doing that. D by dx of x, then you cancel d and d, then you cancel x and x, and then you tell the answer is 1. Although this time the answer is correct, it's matching with the right answer, but the method is wrong. If there is physics police, they can even catch you for this mistake. Actually, d by dx is an operator. In mathematics, you have seen the plus, it is a mathematical operator. You have seen the minus, you have seen multiplication, you have seen division. Similarly, d by dx is a mathematical operator. Getting my point? You cannot destroy the operator, such as if someone asks you to write the plus sign, do you ever write one line here and other line there? Can you do that? No, it's not feasible, it's wrong. Similarly, can you write d by dx as like this, d here, dx there? No, you can never do that. It's a symbol. Wherever you will be using it, you will be using it like as written here. Getting my point? I'll take another example. Suppose d by dx of root x. Can you report your answer in comment box? X to power 1 by 2 can be solved using this rule. 1 by 2 x to power 1 by 2 minus 1. Getting my point? It will be 1 by 2 x to power minus 1 by 2. Clear? In simple manner, if you want to write, it will be 1 by 2 root x. Another example, d by dx of x to power minus 1 by 5, let's say. Simple way, same thing, minus 1 by 5 x to power minus 1 by 5 minus 1. You can simplify it further. Last example, since I have some space here, d by dx of x to power 100. Now you report the answer. Do it quick. 100 x to power 100 minus 1, which is 100 x to power 99. Note it down, then we'll take up the third rule. Rule number 3 is known as the constant multiplication rule. If you have d by dx cu, then answer will be c du by dx. Taking up example number 1. Suppose d by dx of 5x to power 9. You have such a question. Now you compare the things. C is a constant, 5 is a constant, and u is a differentiable function. X to power 9 is a differentiable function. Then the constant comes ahead, outside. So this should be written as 5 d by dx of x to power 9. Now do you remember how to solve this thing? D by dx of x to power 9. It's pretty simple for you, I think. 5, and this will be solved using the power rule, the second rule. 5 into this is 9 x to power 9 minus 1. So your answer is 45 x to power 8. Clear? Take the another example. Example number 2. D by dx of 2 by root x. Then how you will simplify it? 2 is a constant. So constant will be taken out and you are left with d by dx of x to power minus 1 by 2. When it will go up, it will become x to power minus 1 by 2. Now you know how to simplify this thing. This 2 is here only and we are going to simplify it. This minus half and then x to power minus half minus 1. This will be the final answer. Minus x to power minus 3 by 2. Getting my point? Taking up one more example here. Example number 3. D by dy of 100y cube. Now you try to answer it yourself. Instead of x, I am using the parameter y. It doesn't make any difference. You can easily use the formula again. Obtain it. 100 is a constant. It will be taken outside, and then you need to operate d by dy of y cube. Now this term can be operated using the rule number 2. So simplifying it here, 100 and operating this will give you 3 y to power 3 minus 1. So your final answer is 300 y square. I hope you get my point. If there is a constant in multiplication with the differentiable function, then you take that constant outside and then differentiate the remaining function. It's pretty important rule. You can note it down. Then we'll take up the rule number 4. Now let's take up rule number 4. It's known as the addition or subtraction rule. It's a pretty simple rule. Suppose you have d by dx of u plus minus v plus minus w. Here u, v, w, they all are differentiable functions. Then you can write as d by dx of u plus minus d by dx of v plus minus d by dx of w. If you have few functions in addition or subtraction, then you can individually operate them. Let's take up here example number 1. If someone asks you d by dx of x square minus 5x plus 10, what should be the answer? How you can simplify this? Here are 3 functions. They are in addition or in subtraction. Then it can be solved individually. D by dx of x square plus d by dx of minus 5x plus d by dx of 10. Getting my point? D by dx of x square using rule 2, what should be the answer? 2x plus, this is a constant. You remember rule 3, constant is in multiplication with the function, then this will be taken outside. So minus 5 will be taken here. You are left with d by dx of x. This is a constant, and differentiation of any constant parameter is always 0. Fine. Let's simplify it further. 2x minus 5, because this will become 1. Taking up another example, d by dt of 100t cube minus 5t. Now you try to answer it. Instead of x, now we are using t. It doesn't make any difference. You will write this as 100 outside and then d by dt of t cube. Similarly, minus 5 will be taken outside, d by dt of t. I hope you understand this step. Constant is in multiplication, then it is taken outside of the differentiation. And if few functions are in addition or subtraction, we can operate them individually. So that's what we have done here. Now operation is pretty simple. 100 will keep on lying here. D by dt of t cube. You remember from the rule 2, what should be the answer? It should be 3t square, and d by dt of t, this answer will become 1. So 5 into 1. Here is your final answer, 300t square minus 5. Pretty simple question. Note down this thing, and then we'll be observing few important formulas of the differentiation. You will see a table on the next screen, and I request you to pause there and note down all those formulas and learn them. They will make your calculations quick and smooth. I hope you have noted down and learnt all the formulas in the table. Now I am taking up the rule number 5. Rule number 5 is pretty important one. We know it by the name of multiplication rule. Suppose someone gives you d by dx of uv, then it will be solved as u d by dx of v plus v d by dx of u. Example number 1. Suppose someone asks us how much is d by dx of x plus 1 x square minus 5x plus 6. You can solve it using this rule. U and v both are the differentiable function. So this can be treated as u and this entire bracket can be treated as v. Now according to this rule, in order to solve it, first you keep the u outside. It means we'll keep the x plus 1 outside and we will differentiate the v. It means x square minus 5x plus 6. Getting my point? Plus now you will keep the v outside. V is x square minus 5x plus 6 and you will differentiate the u. So d by dx of u is this term x plus 1. I hope you get this thing. Now operating the remaining calculation, d by dx of x square. Do you remember the direct answer? Differentiation of x square was 2x. D by dx of minus 5x, minus 5 will come outside and differentiation of x will become 1 and differentiation of this 6 will be 0. No need of writing that. Plus x square minus 5x plus 6 d by dx of x. Differentiation of x with respect to x is 1 and differentiation of this 1 is 0 because 1 is a constant quantity. Fine. This is the final answer. If you wish, you can simplify it further or you can leave it here only. Taking up another example, example number 2. D by d theta of 5 sine theta cos theta. Pause the video here and you give it a try yourself. 5 is a constant, so constant will be taken outside of the differentiation. So you are left with 5 d by d theta of sine theta and cos theta. Then here this can be treated as u and this can be treated as v. Now it's pretty simple. 5 will remain outside and I am simplifying the remaining terms. U will be kept outside, it means the sine theta will be kept outside. Then d by d theta of v, and v there is cos theta, plus now you will keep the v outside, so you have to keep here the cos theta and you have to differentiate the u. So d by d theta and the u there is sine theta. Now from the previous formula table you might be remembering all these values. The differentiation of cos theta gives you what? Differentiation of cos theta was minus sine theta plus this cos theta at its own position. What was the differentiation of sine theta? It was cos theta. So here you will be putting another cos theta. Simplifying it further, 5 and this bracket has cos square theta minus sine square theta. Is it some trigonometric identity? Cos square theta minus sine square theta. Do you remember something? Cos square theta minus sine square theta can be written as cos of 2 theta. So this will be 5 cos of 2 theta. This is the final answer. You can note down the things up to here. Then we'll take up rule number 6. Now taking up the rule number 6, the division rule. This is also an important rule. If we have d by dx of u by v, then it will be solved as v square, keep the v again, and d by dx of u. Then there will be a negative sign, keep the u and d by dx of v. In this manner we have to solve the things. Taking up example number 1 here. If someone asks you d by dx of 10x, from the formula table, do you remember the answer? D by dx of 10x. Its answer was secant square x. I hope you remember it. Now I am going to prove it. This can be written as d by dx of sin x by cos x. 10x can be written as sin x by cos x. This sin x we can treat as u and cos x we can treat as v. So we can utilize this formula. Pay attention. This entire term is u. This entire term is v. Formula says v square. V square means cos x whole square. Then formula says keep the v outside. So keeping the cos x here. And then you need to differentiate the u. D by dx of the u is sin x. Minus is from the formula itself. Then keep the u outside. U is sin x. So keeping the u outside. And then you have to differentiate the v. V is cos x. Okay. Let us simplify the things further. Cos x, the differentiation of sin x is again cos x minus sin x. Differentiation of cos x is minus sin x divided by cos square x. Let's see. Cos square x, and this minus minus will become plus. So here is sin square x divided by cos square x. Cos square x plus sin square x, trigonometric identity, it will be 1. So basically it is 1 by cos square x, and 1 by cos square x is the secant square x. So which is good thing? You solve it completely or you directly learn it? What do you say? Learning the formula table is good for you. It will save your time. If you want the details, they are lying here. In this way we can derive all the formulas, but I'll suggest to learn that entire table honestly. Good? Note it down. Taking up the next example. Suppose d by dt of t square minus 1 by t cube plus 5. You can pause the video here and you can give it a try yourself. I'll be solving it on the board. This entire term can be taken as u and this can be taken as v, and then this formula is applicable. So doing the calculations here, v square, it means t cube plus 5 whole square. Keep the v outside, so t cube plus 5 is kept outside. D by dt of u is t square minus 1. Then there is a negative sign in the formula itself. Now keep the u outside, so t square minus 1 is kept outside, and d by dt of v is t cube plus 5. I hope you all have done in the similar way. Simplifying it further, t cube plus 5, this differentiation d by dt of t square, you remember that, 2t, and differentiation of minus 1 is a constant quantity. Differentiation of any constant quantity is 0, so I am not writing that. Minus sign due to the formula, t square minus 1, d by dt of t cube, it will be 3t square, and differentiation of 5 became 0, and here already we have t cube plus 5 whole square. You can simplify it further, that would be your final answer. You can write it up to here. Then we'll be taking up the rule number 7, the chain rule or the outside inside rule. We will be taking up the maximum number of examples for the chain rule because that's most important one, the chain rule. It's simple one. If you pay attention, you'll get it. I usually call it by the name outside inside rule. I'll tell you why we do so. This rule says, first of all, you will differentiate outside function and then you will differentiate the inside function. I'm directly taking up the examples. Example number 1. Suppose we have d by dx of sine 2x. Have you ever seen any direct formula for such a differentiation? No. You have seen a formula for differentiation of sine x, but you have never seen the formula for differentiation of sine 2x in the formula table. So we will be using the outside inside rule. We will figure out which function is outside and which is inside. Obviously, the sine function is outside and this 2x is the inside function. I hope everyone understands that. Now, first of all, I am going to differentiate the outside function. How you will do that? You imagine this is something, whatever is lying in this bracket, it is something. So you have sine of something. What is the differentiation of sine of something according to the formula table? Differentiation of sine of x was cos of x. So differentiation of sine of something will be cos of something. So I am going to differentiate the outside function. Sine of something will appear here as cos of something, and that something was 2x. Okay. Now you need to differentiate the inside function, d by dx of 2x. This 2 is a constant and x is a differentiable function. 2 will be taken outside of the differentiation. So I am writing that 2 here outside of the differentiation. This cos 2x is already lying and you are left with d by dx of x. How much is d by dx of x? You know the answer, it will be 1. So this term will become 1. So your final answer will be 2 cos 2x. Clear? Taking up another example. Example number 2. Suppose you have d by dx of sine of x square. Can you give it a try yourself? Here the sine function is the outside function and this x square is your inside function. When you differentiate the outside function, sine of something will become cos of something. So cos of x square into, you need to differentiate the inside function. And what is the differentiation of x square? Everyone knows it will be 2x. So writing that 2x here, and already we had cos of x square. Getting it? Pretty simple answer. Taking up example number 3. D by dx of, let's say, sine square x. Give it a try yourself. Actually, it can be written as d by dx of sine x whole square. Now, can you recognize which is outside function, which is inside function? The outside function is this power, and this sine function is your inside function. Rule is simple. First you differentiate the outside function, then you need to differentiate the inside function. I'm going to differentiate the outside function. Something to power 2. How you will solve it? 2 and then sine x power 2 minus 1 n something to power n minus 1 into, you need to differentiate inside function. Differentiation of sine x is what? Cos x. So simplifying it further, 2 sine x and this will become cos x. 2 sine x cos x. From trigonometry, what is that? Sine 2x. That should be your answer. Fine. Now taking up example number 4. D by dx of 2 sine 3x plus 4. You can give it a try yourself. This 2 is a constant, it will be taken outside the constant multiplication rule. Now can you recognize the outside and inside function? This is the inside function and the sine function is the outside function. Now you assume it to be sine of something and then you need to differentiate the outside function first. Sine of something will become cos of something. Then we need to differentiate the inside function, d by dx of 3x plus 4. I hope you remember how to differentiate this. 3 will come outside, d by dx of x will become 1 and differentiation of 4 will become 0. This is your final answer, 6 cos 3x plus 4. You can write up to here. Then on the next screen, we'll be taking up few more questions. And I recommend you to pause the video here and try all these questions yourself. Trick is simple. First you differentiate outside function and then you differentiate the inside function. Taking up example number 5, and it's pretty important in physics. Many times we will be using it. You have to obtain d by dt of a sine omega t plus phi. A, omega and phi are constants. It's given to you. You can pause the video and give it a try. I'm solving it on board. Since a is a constant, it will be taken outside. So it will become a d by dt of sine omega t plus phi. Fine. Now you will be using outside inside rule. I hope everyone can recognize that this is the outside function and this is the inside function. Simplifying the things, a is here, and first of all, differentiation of outside function. You imagine this as something, sine of something. What is its differentiation? Cos of something. So I should write here cos of omega t plus phi into, we need to differentiate the inside function. Inside function is omega t plus phi. Is it okay for everyone up to here? This can be written as d by dt of omega t plus d by dt of phi. Do you agree? And here omega is a constant term. It's given in the language of the question, as well as the phi is also a constant term. Differentiation of phi will become 0 as it was a constant term. And this omega is in multiplication with the differentiable function. T is a differentiable function. So omega will be taken outside. Simplifying it further, here we have a cos omega t plus phi already present, and this omega I am taking outside of the differentiation, and we are left with d by dt of t. This answer everyone knows, d by dt of t. It will become 1. So what will be the ultimate remaining answer? This is the final answer. It's pretty important question in many chapters of physics, such as alternating current, electromagnetic induction. We will be using such equation even in chapter simple harmonic motion. Note it down, and I again request you to try this entire question yourself. And one question, you should give it a try. It's for you. Obtain d by dt of a cos omega t plus phi. Post your answer in comment box. What value you are getting for this? Because if you understood this one, it's similar question. So I am not solving it. You will do it yourself. Okay? Note it down. I am taking up the next example. Suppose you have to solve d by dx of sine of ln x. This is log x. Okay. Do you remember any direct formula of such computation? No. It means it will be solved using the outside inside rule. This sine function is the outside function and the ln x is the inside function. According to the outside inside rule, first of all we'll be differentiating the outside function. So differentiation of sine of something, this ln x can be assumed as something, cos of something, and that something is ln x, into we need to differentiate the inside function. Clear? Differentiation of ln x from the formula table, do you remember? Differentiation of log x was 1 by x. So that 1 by x I am writing here, and cos of ln x. This is the final answer. Taking up another example, e to power, let's say 5x plus 7, and you have to differentiate this. Pause the video here and you can give it a try yourself. It's a simple but good question. Okay, I am solving it on the board. This is your outside function and this power is your inside function. First of all, we'll differentiate outside function, then we'll differentiate the inside function. Differentiation of e to power something, the answer will be again e to power something. This e to power is interesting. E to power x, if you differentiate it, the answer is again e to power x. So when we differentiate the outside function e to power something, its differentiation will also be e to power something, into you need to differentiate the inside function. Inside function is 5x plus 7. Clear? Now the differentiation is pretty simple. E to power 5x plus 7 at its own place, and simplifying this, d by dx of 5x, the 5 will come outside and d by dx of x will become 1. So here the data will be 5 into 1 plus d by dx of 7, differentiation of 7 will become 0, as 7 is a constant number and differentiation of any constant is always 0. So what's our final answer? It is 5 e to power 5x plus 7. Getting it? Let's take few more examples as we have some space available here. Example number 6. D by dx of ln of sin x. It will be solved again using the outside inside rule only. Give it a try. Recognize the outside function, recognize the inside function. This ln is your outside function and this sin x is the inside function. First we'll differentiate the outside function, then we'll differentiate the inside function. So let's go for solution here. I'm differentiating the outside function, log of something, its differentiation will be 1 by something into d by dx of inside function. Inside function is sin x. Differentiation of this sin x will become cos x, and this 1 by sin x is already present here. The cos x by sin x, it can be written as cot of x. Pretty simple answer. Getting it? You can note down these things, then I'll be taking up the next example. Every time we are doing the same thing, first we differentiate the outside function and then we differentiate the inside function. Okay. Taking up example number 7, d by dx of e to power sin x. You can pause the video here and you can give it a try yourself. I am solving it on the board. The e function is the outside and this sin x is the inside. So first of all, we'll be differentiating the outside function. Differentiation of e to power something is again e to power something into. Now you need to differentiate the inside function. Inside function is sin x. Differentiation of sin x we already know is cos x. So final answer is e to power sin x multiplied with the cos x. Clear? Taking up example number 8, d by dx of 1 by 3x minus 2. How you can solve it? Any idea? It can be done by the u by v rule, but I am not doing that. I am using the outside inside rule. See how? This question can be rewritten as d by dx of 3x minus 2 to power minus 1. Do you agree? which is outside and which is inside? This data in the bracket is the inside function and this power minus 1 is the outside function. You know how to do the differentiation now. First we'll differentiate the outside function. So the differentiation of the power, you all remember how you operate that. Minus 1 will be here, 3x minus 2 minus 1 minus 1. Remember that. N something to power n minus 1. Yet we have differentiated only the outside function. Now we need to differentiate the inside function. So d by dx of 3x minus 2. You know the result of this differentiation. 3 is a constant, can be taken outside. Then d by dx of x, that will become 1. And d by dx of minus 2 will become 0 because minus 2 is a constant. So from this entire computation, only the 3 will be coming outside. So our ultimate answer will be minus 3 bracket 3x minus 2 power minus 2. Clear? If you have any doubt, you can light up the chat box. I am taking up few more questions. Example number 9. It's super important. D by dt of 3x square minus 5x plus 7. You can pause the video here and you can give it a try yourself. It's a super important question. I'm solving it on the board. This can be written as d by dt of 3x square minus d by dt of 5x plus d by dt of 7. Simple thing. We have used which rule? The addition subtraction rule. Now the constant multiplication rule can be used. This 3 is a constant, it will come ahead. So 3 d by dt of x square minus 5 d by dt of x plus d by dt of 7. 7 is a constant term, so its differentiation is 0. Fine. Now here the parameter is t and here the parameter is x. So you have to simplify it using the outside inside rule. This power is the outside and this x is the inside. Pay attention. 3 at its own place. First I'll differentiate the outside function. So differentiation of power, how we do? 2 x to power 2 minus 1 n x to power n minus 1 into we need to differentiate the inside function d by dt of x. Clear? This is 5 d by dt of x. Okay. Here is your final answer. 3 into 2, it will make 6 x dx by dt minus 5 dx by dt. It's a very good question. Okay. You can pause the video here and you can note down the things. Then I'll be taking up few more good questions. Taking up next example, example number 9. You have to find d by dx of root cos x. You can give it a try yourself. Pause the video here and I'll be solving it on the board. This can be simply written as d by dx of cos x to power 1 by 2 and we can solve it using outside inside rule. This data is the inside and this is the outside. First we'll differentiate the power and we know how to differentiate the power. N x to power n minus 1. So it will be written as half cos x power half minus 1. We have differentiated the power, the outside function. Now I am going to differentiate the inside function. Inside function is cos x. Okay. You know the differentiation of cos x. It becomes what? Minus sin x. So we'll be writing the data cos x here and minus 1 by 2 into this will be minus sin x. Fine. Here you can sum up your final answer. Minus sin x by 2 root cos x. Easy and good question. Taking up example number 10 here. Suppose you are given that y is equal to 2u cube, comma, u is equal to 8x minus 1. Find dy by dx. Give it a try yourself. I am solving the question here. D by dx of y, and y itself is 2u cube that you have to obtain. Okay. D by dx of 2 is a constant, so I am taking it outside. U cube means what? 8x minus 1 whole cube. Do you agree? Ultimately you have to simplify this thing. Fine. 2 remains outside and this becomes the inside function and this power is the outside function. You know how to simplify the things. First you will differentiate the power and then you will differentiate the inside function. Okay. So n bracket n minus 1. Differentiation of power has been done into, you need to differentiate the inside function. The inside function is 8x minus 1. This differentiation is simple for us. We already know 8 is a constant which is in multiplication with the x, so it will be taken outside. D by dx of x will become 1 and differentiation of this minus 1 will become 0. So ultimately this entire calculation will give you 8 outside. This should be the final answer. Clear? Pause the video here and note down the things. On the next screen, you will get a checkpoint. You should try to solve all those questions yourself for the better understanding. Our next topic is the double differentiation. If you can differentiate a function once, then you can differentiate it twice, thrice, as many times as you wish. So it's not tough for you. I am taking a few examples. Example number 1. You have read the displacement S. Remember the formula? ut plus half at square. Now, if someone asks you to obtain the velocity, then velocity is the rate of change of displacement. So d by dt of s will give you the velocity. It means d by dt of ut plus half at square. Here u is a constant, the initial velocity is a constant, as well as the acceleration a is also constant. Let's simplify it. I am using the addition rule. D by dt of ut plus d by dt of half at square. Okay. U is a constant which is in multiplication with the time, so you can take it outside. So it is u d by dt of t plus a by 2 is also a constant. It can be taken outside. A by 2 d by dt of t square. Fine. D by dt of t, this term will become 1. So here you are left with u into 1 plus a by 2 at its own place. On simplifying this, you will get it. This 2 and this 2 is getting cancelled out. So you are left with what? U plus at. This equation gives us the velocity. I hope you have seen this equation also earlier somewhere. Now after obtaining the velocity, we can easily obtain the acceleration. The acceleration is the rate of change of velocity. It means d by dt of v. This is your velocity v. Okay. Now putting up the data, we can simplify it. D by dt of u plus a is a constant taken outside, d by dt of t. U is a constant according to the given data. So this differentiation will become 0 and d by dt of t will become 1. So you are left only with the a. And if you remember, in these equations, the a is actually the acceleration. Now this a can be written as d by dt of ds by dt, because the v was ds by dt, and this in turn can be written as d2s by dt square. The double differentiation of the displacement gives you the acceleration. Either you write like this or you write like this, both are the same things. So this is how we go with the double differentiation. On the next screen, you'll get a checkpoint. You should pause there and you should try to solve all those questions yourself. Our next topic is the practical application of the differentiation in physics. Many formulas and the calculations in the physics becomes easy with the differentiation. For example, if we know the displacement, then we can represent the velocity as rate of change of displacement, means d by dt of s. And if we know the velocity, we can easily obtain the acceleration. The acceleration will be the rate of change of velocity, means d by dt of v. Another practical example, the instantaneous current I means d by dt of q. The instantaneous power is the rate of work done, so it is d by dt of w. Here w is the work done. The force is the rate of change of linear momentum, so d by dt of p. Here p is the linear momentum. Getting it? There are thousands of the examples which can be related with the differentiation. Suppose q is equal to 3t square minus 5t plus 6 coulomb. Find the current at t is equal to 2 seconds. It can be easily done. We know that the I is equal to the rate of flow of charge. It means d by dt of q. Do you know how to solve it? First you'll use the addition subtraction rule. So d by dt of 3t square minus d by dt of 5t plus d by dt of 6. This 3 will be taken outside, d by dt of t square. 5 will also be taken outside, d by dt of t. Differentiation of 6 will become 0 as 6 is a constant quantity. Now simplifying the remaining term, 3. Differentiation of t square will become 2t to power 2 minus 1 minus 5, and differentiation of t with respect to t will become 1. So 5 into 1. Clear? This is the current. And the question is asking the current at t is equal to 2 seconds. Current at t is equal to 2 seconds can be obtained by putting the time is equal to 2 in this equation. Let us simplify it a little bit. I comes out to be 6t minus 5. So the current at 2 seconds is 6 into 2 minus 5 ampere. It will become 7 ampere. You can note down and then we'll go further. Taking a few more examples, you can see an expanding sphere on the screen. The radius is increasing at a rate of 0.1 centimeter per second. So at some moment when the radius is equal to 6 centimeter, you need to find the rate of change of area. You can pause the video and you can give it a try yourself. I am solving it on the board. The area of a sphere 4 pi r square. So what we need actually is d by dt of that area. 4 pi is a constant, and in the differentiation when the constant is in multiplication it's taken outside. So you have to solve the d by dt of r square. Do you remember how it can be solved? Correct, outside inside. Actually this power will serve as the outside and this r will serve as the inside function. Now the calculation is pretty simple for us. 4 pi, first I am differentiating the outside function, this power. Differentiation of power you know, 2 r2 power 2 minus 1. Then we need to differentiate the inside function. So d by dt and the inside function is r. Okay. This is equal to 8 pi r d by dt of r. Now the question was asking us the rate of change of area when the radius was 6 centimeter, and the dr by dt is already given as 0.1 centimeter per second. I am submitting all the values. What sign we should put here with the dr by dt? Positive or negative? The radius is increasing, so the rate of change must be positive. This is the rate of change of area with respect to time. You can write up to here, then we'll take up the next example. Here is the next question. A sphere is continuously shrinking and the radius is shrinking at a rate of 0.2 centimeter per second. Some moment when the radius of sphere was equal to 10 centimeter, then at that moment you need to obtain the rate of change of volume of the sphere. Getting the question? You can pause the video here and give it a try yourself. I am solving it on the board. The volume of the sphere is given as 4 by 3 pi r cube, and question is asking us the rate of change of volume. The 4 by 3 pi is a constant, so can be taken outside, and you have to simplify the d by dt of r cube. Here this power 3 is the outside function and this r is your inside function, and then you can simplify it using the outside inside rule. 4 pi by 3 is a constant kept outside. I am differentiating this power first, so it will be 3 r2 power 3 minus 1 n x2 power n minus 1, that kind of format we are using. Then you need to differentiate the inside function. 3 and 3 is getting cancelled out, so you are left with 4 pi r square dr by dt. Okay, now pay attention. I am going to put the numerical values. 4 pi, the radius was given to you in the question is 10 centimeter. What you should put at the place of dr by dt? Speak up. 0.2 centimeter per second. And what should be the sign here? Positive or negative? According to the language of the question, the radius is continuously decreasing. So the rate of change here is actually negative. This is the most important part of this question. If something is decreasing, it means its rate of change will be negative. Actually, rate of change could be anything, positive or negative or zero. Take an example. Suppose you have a bottle and that bottle is empty. What is the rate of change of volume of that bottle? Rate of change of volume of that bottle will be zero. Volume is fixed for that bottle. Got it? Second example. Suppose you have a glass and you are pouring down water into the glass. Now, the rate of change of volume of the water inside the glass with respect to time, it will be positive or negative? It will be positive because the volume of water inside the glass is continuously increasing. Getting it? Take the third example. Suppose you have a pot and from that pot the water is leaking. So the rate of change of volume of the water for that particular pot will be negative. The amount of water is decreasing with respect to time. Getting my point? Fine. You can simplify it further and you will get your final answer. It's a good question. You can note it down, then we'll go further. Let's have the next question. We are given a rectangle whose length is decreasing with the time and the width is increasing with the time. And when length is 10 centimeter and the width is equal to 6 centimeter, you have to find the rate of change of perimeter as well as the rate of change of area. Question is simple. You can pause the video here and you can give it a try yourself. I am solving it on the board. Perimeter of rectangle is twice length plus width. And question is basically asking you the rate of change of perimeter. This 2 is a constant, so I am taking it outside, and here is d by dt of L plus W. Okay. Calculation is pretty simple. D by dt of L plus d by dt of width. Looking at the language of the question, what you will put here at the place of d by dt of L? minus 3 centimeter per minute. Why negative? Because the length is decreasing and width is increasing at what rate? 2 centimeter per minute. This calculation is pretty simple. Your answer will come out to be minus 2 centimeter per minute. Done. I'm solving the second part of the question. Area of the rectangle is given as length multiplied with the width, and the question is asking the rate of change of area also. So here we'll write d by dt of L and W. This can be solved using which rule? The multiplication rule. So I'll keep L outside and I'll differentiate the width. Next time I'll keep the width outside and will differentiate the length. Okay, length is given as 10 centimeter. How much is the rate of change of width? The width is increasing at a rate of 2 centimeter per minute. The width is given as 6 centimeter and the length is decreasing at a rate of minus 3 centimeter per minute. Getting it? Note it down. Here is the next important question. A spotlight is rotating and the point on the wall will go up. So you have to find the speed of the spot. The rate of change of the angle of the spotlight is given as 0.1 radian per second. I hope you understood the question. Pause the video here and give it a try yourself. First of all, we will recognize the variables. The height of the point on the wall will keep on changing because that spot is continuously moving on the wall, and the angle theta is also a variable. So first of all, we'll relate the variables and then we'll differentiate the variables with respect to time. Suppose here is the light. From this light source, the wall is 3 meters away. On that wall, there is a spot due to the light. Let's say that spot is named as P. And since the theta here is continuously increasing, it's given to us in the question that rate of change of theta is 0.1 radian per second. So this point P will go up and let's say its speed we write as V. Our target is to obtain this V. The height of point P at some moment of time we assume as y from here. Fine. I'm writing the tan theta in this triangle. The tan theta will be written is equal to y divided by 3. Okay. So y is equal to 3 tan theta. Here the variable is y because as the point will go up, the y will keep on increasing, as well as the variable is theta. As the light is rotating like this, theta will keep on increasing. It means we are going to differentiate the things with respect to time. So this will be d by dt of y, and 3 is a constant, has been taken outside, d by dt of tan theta. Okay. Keep d by dt of y as v. The rate of change of y will give you this v is equal to 3. D by dt of tan theta. This will be solved using the outside inside rule. This tan function is your outside function and this theta is your inside function. Okay. Now simplifying the things, first I'll be differentiating outside function. So differentiation of tan of something is the secant square something. So here you will write secant square theta. Now you need to differentiate inside function. Differentiation of inside function is d by dt of theta. Getting it? Question is asking the numerical value of v. That now you can obtain. Put here theta is equal to 45 degree and put here d theta by dt as 0.1 radian per second. You should make it as a habit. All the numerical values you should only put at the end of the calculation. Getting it? Then there will be very less chances of the errors. So I am going to put the numerical values. 3 secant square 45 degree into 0.1. And now we can do the final calculation. Secant square 45 degree will become 2. 2 into 3 is 6. 6 into 0.1. The answer must come out to be 0.6 meter per second. You can note it down. Then we'll be taking up the next good question. Taking up the next question, it's pretty interesting one. There is a person which is moving away from the lamp post with constant velocity v. You have to obtain the rate of change of length of the shadow as well as the speed of the tip of the shadow. You can pause here and you can give it a try yourself. Then you can match your answers with the board. First of all, we'll relate the variables and again we'll differentiate them with respect to time as we did in the previous question. Here, what is variable? The length of the shadow is variable as well as the distance of the tip from the pole is also variable. Here is that person, let's say. This has height small h, this angle is, let's say, theta. Okay. Now, this distance of the person with respect to the lamppost is given as A and the length of the shadow is given as B. We are going to relate all these parameters. Let's say we write the tan theta. Then tan theta in this triangle will be equal to what? Capital H divided by A plus B. And tan theta in this smaller triangle will be equal to small h divided by B. Okay. Since B is changing as the person will move, the length of the shadow will keep on changing. So I am trying to obtain the B from this entire computation. Pay attention. Doing the cross multiplication, this will become BH is equal to HA plus HB. Do you agree? Taking this HB here, so B common, capital H minus small h is equal to HA. And here you get the value of B. B is equal to HA divided by capital H minus small h. B is changing with respect to time. So we will differentiate it with respect to time. So here we are left with d by dt of B is equal to, this small h is constant, the height of person. This capital H is also constant. So these constants I'll keep out of the differentiation. So small h divided by capital H minus small h, d by dt of A. Getting it? What is this d by dt of B? The rate at which the length of shadow is increasing. Okay. So here you will get your first answer. The rate at which the length of shadow increases, that will be equal to small h divided by capital H minus small h multiplied with V. This dA by dt is actually equal to V. Why? This length A is changing and rate of change of this length will give you the V. Fine. You can note it down. Then we'll solve the second part. For second part, the tip of shadow will be lying here. The rate at which the tip of shadow moves, it should be equal to d by dt of A plus B. Do you agree? From the pole, the tip of the shadow is at a distance A plus B. As the person is walking ahead, the A as well as B both are changing and the rate of change of the length A plus B will give you the speed at which the tip of shadow is moving. So let us simplify this calculation. It can be written as d by dt of A plus d by dt of B. D by dt of A, the rate of change of A, we already know is V, plus d by dt of B is already available. It is small h divided by capital H minus small h multiplied with V. V can be taken out common here. This is the final answer. You can note it down. It's pretty important question. And a similar question you'll find in the checkpoint. That question you should try to solve yourself. Here is the next question. It's a brilliant one. A sphere is continuously expanding and you have to relate the speed of any point on the surface of the sphere with the instantaneous radius of the sphere. 4 options are also given. You have to choose any one of them. So you can pause here and you can give it a try. I'm solving it on the board. The solution part is pretty simple. First of all, we will be writing the density. The density of the sphere is written as mass divided by the volume. Mass is given as m and the volume is 4 by 3 pi r cube and density is given as rho. Okay. R cube I am taking in the LHS, so we are left with 3m by 4 pi rho. Fine. And if we take the power 1 by 3 on both sides, then R will be equal to 3m by 4 pi power 1 by 3 and 1 by rho power 1 by 3. Do you agree? This 3, this m, this 4, this pi is everything constant here. Pay attention. All these parameters here are constant according to the language of the question. The mass is already given constant in the question. So this constant I can write as k. Then R is equal to k rho to power minus 1 by 3. Do you agree? This relation looks a bit simple and our calculation will become faster with this. Now the radius is changing with respect to time. So we will differentiate the things with respect to time. D by dt of R, the constant is taken outside of the differentiation. D by dt of rho to power minus 1 by 3. How you will simplify this differentiation? It will be solved using the outside inside rule. Can you recognize which is outside function, which is inside function? This power is the outside and this rho is the inside. This dr by dt will be written as the speed of any point on the surface of the sphere, because the rate at which the radius is changing will give you the speed of any point on the surface. So here you can replace v and remaining calculation we are doing k. I am differentiating the outside function. You know how to differentiate the power. Minus 1 by 3 rho power minus 1 by 3 minus 1, and then we need to differentiate the inside function. The differentiation of inside function is d by dt of rho. Do you agree? Okay, let us rearrange the things. V is equal to minus k by 3, k is constant, 3 is constant, and I am trying to rewrite this term. This rho to power minus 1 by 3, we are keeping it separate, and this rho to power minus 1 we can write as 1 by rho, and here is the d rho by dt. See, this is something useful for us. 1 by rho d rho by dt is a constant or variable? Is a constant according to the language of the question. This k by 3 with a negative sign is also a constant. It means you can directly say that v is proportional to rho to power minus 1 by 3. And rho to power minus 1 by 3 in turn is proportional to what? The radius r. It means this speed is directly proportional to the radius r. Here is the final answer. It's a good one. You can pause here and you can note it down. And I request you to try it once yourself also. Then you'll get a checkpoint. All those questions as usual, you should give them a try. And then we'll be having the last topic of this video, maxima and minima. Let's start the maxima and minima. Suppose you run a company, then you want to maximize the profit and you want to minimize the losses. So if you can make a mathematical equation, then you can easily find for which values you'll obtain the maxima and for which values you'll be getting the minima. Let's go through the theory first. Suppose there is a curve. If you focus on this point, here you are getting a maxima. Okay. And if you focus on this point, here you are getting a minima. So first of all, we'll be reading about the maxima, then we'll talk about the minima. Let's draw the diagram once again. This is indicating the maxima. Fine. At the maxima, if you check the slope, how much is this? The slope here is 0. And slope can be written as d by dx of y, and that is equal to 0. Do you agree? Okay. Just before the maxima, if you check somewhere here or here or here, how much is the slope? Positive, negative or 0? Line is inclined like this, acute angle. So the slope of this line is positive. Get my point? And if you check the slope of some point here after the maxima, then this slope is negative. So you can write the mathematical formulations for maxima. At maxima, first thing, the slope means dy by dx is equal to 0. Getting it? Wherever the curve will attain its maxima, the slope will be 0. Second point, this rate of change of slope is positive, negative or 0. Think about it. Initially the slope was positive, then it became 0 and finally it is turning into negative. From positive, if you are going towards negative, it means the data is decreasing. That's why the rate of change of slope is less than 0. So here also you can write less than 0. Getting my point? So in mathematics or in physics, wherever you find this term maxima, you should immediately think of these two lines. At maxima, the slope will be 0. And the second thing, the double differentiation will be less than 0. Getting it? Let's talk about the minima. This is x-axis, this is y-axis, and we have some function like this. Here you get the minima for that particular function. At minima, the slope is 0. Slope means d by dx of y, which is 0 here at the minima. And if you check the slope here, then it is negative. And if you check the slope here, then it is positive. So if someone asks us what is the condition for a minima, what we should be replying? The first condition for the minima will be identical to the condition for maxima. The slope means d by dx of y should be equal to 0. And the second thing, rate of change of slope. Now can you tell me how much is the rate of change of slope? Here the slope is negative, then it becomes 0 and then it becomes positive. Some quantity is going from negative towards positive. It means that quantity is increasing. So the rate of change of slope here is greater than 0. And the rate of change of slope can be written as d by dx of dy by dx. It should be greater than 0. Mathematically, you can rewrite this as d2y by dx square greater than 0. And same thing here can be rewritten as d2y by dx square less than 0. I'll be taking numerous good questions to illustrate all these things. You can write up to here. The sum of two positive numbers x and y is such that x plus y is always equal to 100. Then you have to find the maximum value of the xy. It's a pretty interesting question. You can solve it even without using the pen. You can think of few values and you'll immediately get the answer. I'll solve this question in two ways. First, I'll use the maxima minima and then we'll be solving it logically also. So let's start. It's given that x plus y is equal to 100. We call it equation number 1. And p is equal to xy. The multiplication of x and y we are defining as product p. The y from this equation can be replaced here. Shall I write 100 minus x? Do you get this replacement? Y is 100 minus x. So it will become 100x minus x square. We are naming it equation number 2. Now, according to the question, you want to maximize the p. For maximum value of p, what you should be doing? Number 1, the slope or the first differentiation should be equal to 0. We know how to simplify it. 100 is a constant, so it can be written outside. D by dx of x minus d by dx of x square. This all is equal to 0. 100 here into 1, d by dx of x, this entire parameter becomes 1, minus d by dx of x square, I hope you remember, it becomes 2x. So when you simplify it, x comes out to be 50. If x is 50, what should be the value of y from this expression? When x is equal to 50, then y is also 50. Okay. If x is 50, y is 50, then what is the maximum value of this product? 50 into 50 means 2500. Is it okay? Here is the second method of the calculation. Suppose here I take up x, here I take up y, and here we talk of xy. Suppose x is 10 and y is 20. Will it satisfy this condition x plus y is equal to 100? No, this value is wrong. Suppose x is 10, y is 90. Will it satisfy this condition x plus y 100? Yes, it is satisfying this condition. Then you obtain the xy as 900. Suppose x is 20 and y is 80. Will it satisfy this condition? 20 plus 80 is 100 and this product will be 1600. Getting my point? Suppose x is 1 and the y is 99. How much is the product? 99. So for which value of x and y you will obtain the maximum product here? Think about it. You choose x is equal to 50, y is equal to 50 and the product will be 2500. So note it down, then we'll go further. Here is the next good question. We are given a rectangle whose perimeter is 400 meter and we have to find the individual values of length and width in such a manner that the area of rectangle becomes maximum. It's a simple but good question. You can pause the video here and give it a try yourself. I'll be solving the things on board. The perimeter is always written as twice length plus width. And that perimeter was given as 400 meter. So from here you'll get the value of length plus width is equal to 200 meter. Call it equation number 1. Area is length into width and I'm going to replace the width from equation number 1. What I should write? The width will be 200 minus L. Getting it? Simplifying this, you'll get 200L minus L square and you can name it equation number 2. Few smart student might immediately tell the answer looking at this equation. Is it bit similar to the previous calculation, previous question? Now you can immediately tell the maximum value of area. Post your answer in comment box, then I am solving the things on board. For maximum value of area, mathematically the first differentiation should be equal to 0. Okay, let us simplify the things. D by dl of 200L minus L square should be equal to 0. We know how to differentiate such things. 200 d by dl of L minus d by dl of L square is equal to 0. This is 200 into 1 minus 2L is equal to 0. Differentiation of L square will become 2L and this differentiation everyone knows is equal to 1. So from here L comes out to be 100 meter. If L is 100 meter, how much should be the width? Pretty simple answer. The width should also be 100 meter. If the length and width both are 100 meter each, then what should be the maximum value of area? Anyone can tell. 10,000 meter square. Now, could you obtain that answer directly? It's similar to the previous question. You can note it down. It's a good one. I'll be taking up the next question then. Here is the next question. Y is equal to x cube by 3 minus x square, and we need to find the maximum and minimum value of y. We can use the differentiation, we can use the maxima and minima, and we'll get the easy answer. So I'm starting the solution here. First of all, we are obtaining d by dx of y is equal to 0. Y is given as x cube by 3 minus x square. So let us differentiate the things. D by dx, 1 by 3 is a constant in multiplication with the function, so I am taking it outside, and here we are left with d by dx of x square. Okay, 1 by 3, d by dx of x cube, this answer I hope you remember, comes out to be 3x square, and this will become 2x is equal to 0. Simplifying it, 3 is getting cancelled out, so you are left with x bracket x minus 2 is equal to 0. So the values of x from this computation will come out to be 0, as well as x can be equal to 2. Do you get this? After obtaining d by dx, I'll go for d2y by dx square, because these things will be required in the calculations. d2y by dx square means d by dx of dy by dx, and this thing is actually available to us. The dy by dx was x square minus 2x. You have solved the dy by dx already, so it can be written as x square minus 2x. D by dx of x square minus 2 is taken outside, d by dx of x, so it will be equal to 2x minus 2. This is your d2y by dx square. Keep these two values ready. dy by dx is equal to 0 and d2y by dx square. Now we are going for the conditions of maxima and minima. Suppose you want the maxima. For maxima, we know the first condition, dy by dx must be equal to 0, and the second condition, d2y by dx square should be less than 0. Getting my point? So let us satisfy these two conditions. When you do dy by dx is equal to 0, then what you get? X is equal to 0 and x is equal to 2. Do you agree? When you do d2y by dx square less than 0, d2y by dx square less than 0, it will give you what? Simplify it. 2x minus 2 should be less than 0, 2x should be less than 2, and x should be less than 1. X should be less than 1. It means which value is acceptable for the maxima? For maxima, the acceptable value will be only x is equal to 0, because the x must be less than 1. You get this? I am going for the conditions of minima. For minima, the first condition is dy by dx is equal to 0. Solving that condition, we know we'll get x is equal to 0 and x is equal to 2. And the second condition for minima, d2y by dx square should be greater than 0. d2y by dx square should be greater than 0 means 2x minus 2 should be greater than 0. It means the x should be greater than 1. X greater than 1, which value is permissible here for minima? It means x is equal to 2 is the permissible value for the minima. Getting my point? Now we can easily obtain the maximum and minimum values of y. I am doing the calculations here. Suppose we want the maximum value of y. then maximum value of y will be obtained using x is equal to 0. I am putting here x is equal to 0. 0 cube by 3 minus 0 square, so answer is 0. Then we want the minimum value of y. The minimum value of y will be obtained using x is equal to 2. So let's put it here. 2 cube by 3 minus 2 square. So it is 8 by 3 minus 4. So the final computation is equal to minus 4 by 3. Okay, it's a pretty good question. I'm repeating the things again. For maxima, these two conditions should get satisfied, and for minima, these two conditions must get satisfied. Using these conditions, we obtain the appropriate values of x. The maxima of this function is lying at x is equal to 0 and the minima of the function is lying at x is equal to 2. When you feed these values back, you will get the maximum and the minimum possible values of y. Fine, note it down. We'll take the next question then. We are given a function and we have to check, is there any horizontal tangent possible? It's a pretty simple question. Wherever the tangent will be horizontal, how much will be the slope? 0. And slope means what? dy by dx. So basically you have to make the dy by dx 0. That will give you the correct answer. Let's differentiate. Differentiation of x to power 4 is 4x cube, and here the differentiation of x square will become 2x. 2x into 2 will make it 4x. Differentiation of 2 will become 0 because 2 was a constant. Let us simplify this. You will get the roots. So x cube minus x is equal to 0. X square minus 1 is equal to 0. So it will give you three values of x. X is equal to 0, x is equal to 1 and x is equal to minus 1. And you can see the diagram. At these three locations of the x, you have the horizontal tangents possible. It's a nice question. You can note it down. Then I'll be taking up the next one. Here is the next question. If a ball is thrown up, then how much time will it take to reach at its highest point? When the ball will reach at its highest point, what is the rate of change of height at that point? Ball has already attained the maximum height. Then the rate of change of the height at that point will become 0. That way we can solve the question. So I'm starting the solution part. At highest point, the ball cannot go further up. So the rate of change of height has to become 0. Do you agree with this? So d by dt of ut minus half gt square should be equal to 0. U is a constant, so I am taking it outside. Half g is also a constant, so we are taking it outside. I hope you know such kind of differentiations. U into 1 minus half g, and this differentiation is 2t. Differentiation of t square is 2t. 2 here is getting cancelled out, so you are left with u minus gt is equal to 0 and t will be equal to u by g. It's pretty important answer. The same thing you will see again in the chapter rectilinear motion. So if I throw this up, then it will take the time u by g to reach at its highest point. Getting my point? Note it down. Then we'll take up the next good question. You need to find the maximum possible volume of a cylinder which can be fitted into a sphere of radius r. It's a brilliant question. You can pause the video here and you can give it a try, and I'm solving it on the board. Suppose we have a sphere and the radius of sphere we consider as r. In this sphere we want to fit a cylinder of maximum possible volume. So let's say we imagine a cylinder like this. The cylinder is having the height, let's say 2h. This is h as well as this is h. The total height of the cylinder we have assumed as 2h. Okay. Actually, there could be many cylinders. You can imagine a cylinder like here. You can imagine a cylinder like here. This blue cylinder is having the maximum possible volume inside the sphere, and that was our target. Let's say we try to obtain the radius of the cylinder. For that we will be using Pythagoras theorem in this triangle. This radius of the sphere was r. So if we use the Pythagoras theorem, h square plus r square should be equal to capital R square. So r square is equal to this thing. Do you agree? Now I am going to write the volume of cylinder. Volume of cylinder had the formula pi into radius square into height. Now putting up the value of r square here, pi into r square minus h square into 2h. Do you agree with this volume? According to the question, this volume should be maximized. That calculation we are doing here. For maximum volume of the cylinder, we know that the first differentiation of the volume must become equal to 0. Here h is only variable, so we are doing the differentiation with respect to h. I'll use the addition subtraction rule. So d by dh of 2 pi r square h minus d by dh of 2 pi h cube is equal to 0. Here we'll take the constants outside. 2 pi r square, everything is constant. Okay. Let us simplify this. 2 pi r square d by dh of h, it will become 1 minus 2 pi d by dh of h cube is 3h square. Clear? Here 2 pi is getting cancelled out. So the r and h can be related very well. Now we can easily obtain the maximum volume here. For maximum volume, we'll submit this value of h in this function. So Vmax is equal to 2 pi and h is written as r by root 3 multiplied with the r square minus r by root 3 whole cube. I hope you get this computation. When you simplify, it will be 4 pi r cube by 3 root 3. It's pretty important answer. The same question can be given in another format. Let's say you want to fit a cube of the maximum possible volume inside this sphere, then do the calculation. You have to go in the same way. I hope you get this idea. You can note it down, and then we'll be taking up the last and the most interesting question of this video. Here is the last and the most interesting question of the differentiation. You people are already familiar with the Patlu and Motu. Patlu is standing here on the sidewalk and the Motu is under the water at a depth of 10 root 3 meter. The horizontal distance between Motu and Patlu is 100 meter. The Patlu should choose which path so it can reach to the Motu in the minimum time. That we have to obtain. My first question is, how many such paths are possible? Number of paths. In how many ways the Patlu can go to the Motu? The answer is infinity. Where you have read it that earlier in the optimization problem. Recall it. See, the Patlu can directly jump into the water and then swim toward the Motu. The Patlu can run along the sidewalk and then jump towards the Motu. Understand? Or if they are very good friends, Patlu can keep on running on the sidewalk. Let the Motu sink down. Is it a possibility? Anyways, other possibility, the Patlu runs along the sidewalk for some moment and then it swims toward the Motu. So there are infinite possibilities. out of those infinite possibilities, there will be one possibility for which the time taken to reach to the motu will be minimum. So in order to solve the question, we will define an expression of time and we will minimize that expression of time using the differentiation. Let's start the solution part. First of all, let us obtain the time. What we assume that, let's say Patlu runs for a distance x on the sidewalk and then Patlu swims towards the motu along this path. Fine. So this distance is 100 minus x, and you can easily obtain this distance using Pythagoras theorem. 100 minus x whole square plus 10 root 3 whole square. Getting it? Now we can easily define the time taken. Time is equal to distance by speed. The distance traveled by the Patlu here is x. So x divided by the speed is 10 on the sidewalk plus the distance traveled in the water. Distance traveled in the water is directly visible to us. It is 100 minus x whole square plus this distance is 300 divided by the speed in the water, which is equal to 5. Do you understand this function of time? Here what is variable in this function? X is variable. Patlu can walk up to here and then jump into the water. Patlu can go up to here and then jump into the water like this. So in this entire parameter, the x is variable. For time to be minimum, the first differentiation of the time should be 0. So we should write d by dx, because x is variable, of t is equal to 0. Getting it? Let us start the differentiation. 1 by 10 is a constant which is in multiplication with the x. So it can be taken outside of the differentiation. So I am writing 1 by 10 d by dx of x plus 1 by 5 d by dx of root of 100 minus x whole square plus 300. This all should be equal to 0. Okay. D by dx of x will become 1. So here we will have 1 by 10 plus 1 by 5. And this will be solved using the outside inside rule. Which function is outside and which is inside? This entire data is the inside, and this root, this power half, is the outside. We know how to differentiate the powers. It will be written as half 100 minus x whole square plus 300 to power half minus 1. See, this bracket had the power half. So half comes here and then this quantity power half minus 1. Differentiation of power has been done into d by dx of inside function. Inside function is 100 minus x whole square plus differentiation of 300 will become 0 because 300 is a constant. So I am not writing that. This all must be equal to 0. Simplified, 1 by 10 plus this 1 by 5 into 1 by 2 will also become 1 by 10, and here will be 100 minus x whole square plus 300 to power minus 1 by 2 into d by dx of this will be again done using the outside inside rule. Here this power 2 is outside and whatever lies here is the inside function. To differentiate this power 2, we will write 100 minus x to power 2 minus 1 into d by dx of the inside function, and inside function is 100 minus x. This all must be equal to 0. Agree? Computing it further, 1 by 10 plus 1 by 10, and this will become 1 by root of 100 minus x whole square plus 300 into 200 minus x. D by dx of 100 will become 0 because 100 is a constant, and d by dx of x will become 1. So ultimately here you will be left with -1 because there is a minus sign already here. D by dx of x became 1. This all should be equal to 0. Okay. Now we have to simplify this thing, and on simplifying you will get x is equal to 90 meter. This is pretty interesting answer. I have the shortage of the space on the board, so I recommend you to do this remaining calculation. So what Patlu should do, he should run 90 meters on the sidewalk and then he should swim directly towards the Motu. In that way he can reach to the Motu in the minimum time. Okay, so this video is over. You can try this question yourself, you can do this calculation, and in the next part you'll be getting a checkpoint. You can pause there, you can give it a try yourself, and then you'll get the answer of all the checkpoints. Stay awesome. Take care.